welcome back to your channel once again. We are continuing the journey of discussing the solution for JEE Advanced 2026 paper 1. So here we are finally entering section 3 and this is question number 9. Basically it's a question from the oscillation. Let's proceed with the question. They are saying a tank contains two immiscible liquids of density 6 rho and 2 rho. The higher density liquid is filled to height of L by 2 from the bottom. A thin rod of rho, density rho and length L is fully immersed and hinged at the bottom. Here it is hinged at this point. It can oscillate freely. It is shown in the figure. If the rod is slightly disturbed from the equilibrium position, the time period of the oscillation is this. We have to find out the value of n. So definitely we'll find out the value of n, and for this kind of questions, you know, as usual, the JEE finally when they will release their official key, they will give the range of the answers. So don't worry, let us solve. Here we will talk about a small oscillation, so don't have to worry much about the derailment of the meta center. So don't get confused with those things. So here what I will simply do that we will consider that the rod is tilted here, right? And so there are two buoyant forces acting on this. I mean, let me take it a little bit inside this. So yeah, so here what we can say that at this particular point, here one buoyant force will be acting in this direction. Here one buoyant force will be acting in this direction. So these two buoyant forces, and I will assume that this angle is to be theta, small angle disturbed. So what will be the buoyant force acting here for this upper end? So here the liquid is having density 2 rho. So I can write A L by 2. So that becomes its volume 2 rho into G. Similarly, here this buoyant force we can mention it to be that is equal to A L by 2 6 rho into G, correct? And apart from all these forces, from here downwards from the midpoint, mg will act. So there we have to balance the torque. We have to check net torque is equal to I into alpha, correct? So how much buoyant force we are getting here? To buoyant force, if I call this force to be F1 and if I call this force to be F2, so F1 we have written AL by 2 rho into G. 2 gets cancelled up, so it becomes AL rho into G, whereas F2 will become A into L by 2 6 rho into G, so that becomes 3AL rho into G. If I talk about the weight of this will become A into length, density of the rod is rho into G, right? So these are the values that we need. Now I will take this diagram once again, and in this diagram we will cross check this one. Check this out. So here is a rod, and this angle we have taken to be theta. Now I am going to take torque about this particular point. So if I take torque about this point, so tau net, how much it becomes? Please check carefully that this distance here, so I'm talking about from this point, so here F2 is acting, so this force is F2 over here, and over here the force is said to be, here the force is said to be F1. So this distance inside, please do this calculation carefully, do not make it in a hurry. So this is L by 2, and through the point the buoyant force is acting is half of that, so that will become, this distance will become L by 4. So if this is L by 4, so this perpendicular distance here, this will become L by 4 sine of theta. So now it will be easy for you. So this will be F2 L by 4 sine theta plus F1. What about this distance? Now again, please calculate. So up to, from here to here it is L by 2. From here to here it is L by 4. So from the point of hinge to this point here, it becomes 3L by 4. So this will become F1 into 3L by 4 sine theta minus mg into L by 2 sine theta. Let's proceed with the calculation. So as you can check from here, I can take L by 4 sine theta common from these two terms. It is coming F2 plus 3F1 minus mg L by 2 sine theta. Go for calculation. L by 4 sine theta. F2 we have reduced to be 3AL rho g plus 3F1 means it becomes same 3AL rho g minus mg into this is mg is already AL rho into g into L by 2 sine theta. So how much this is coming? Please cross check once again. So this is 6 by 4 means it becomes 3 by 2. So we can write 3 by 2 AL rho g into sine theta minus AL, sorry, it will become AL square. So this is also equaling A rho L square sine theta divided by 2 into g. So 3 by 2, 3 minus 1, this is becoming simply 3 by 3 minus 1 is 2, 2 gets cancelled. So it is becoming AL square rho g into sine theta. Since we are talking about for small oscillation for small theta, sine theta is nearly equal to theta. So tau net will become AL square rho g into theta, that is equal to I into alpha. Since the rod is oscillating about the end point, so we can write 1 by 3 ml square into alpha. So putting the values once again, AL square rho g into theta is equal to 1 by 3 m means AL into rho into L square into alpha. AA gets cancelled, rho gets cancelled, here L square gets cancelled. So alpha we get 3g by L into theta, which is equal to omega square into theta. So by comparison, omega becomes under root of 3g by L. So T here will become 2 pi under root of L by 3g. So now let us go on checking the values that they have given. This is, they are saying 2 pi by n under root of L by g. So if I compare this result, that is coming to be 2 pi by root 3 under root of L by g. So the value of n is coming to be root 3, that is approximately 1.7. Don't worry about the result, you will be given a solid range for this. So this is the technique, how you can solve it. I hope you have enjoyed this. If you have enjoyed, do like, share and subscribe. See you in the next video. Bye bye.